just in case you're still a bit fuzzy, right? What's this part mean? I'm translating. I'm just lazy to write out the full sentence, okay? It means x and y are integers, and they're positive integers. That's what the question actually says. But you have to find to write it like that, okay?
Oh, do you factor?
Okay, so I'm required to prove this top line, okay? And the question is, how do I begin? Now remember I was saying just now, right? If I'm asked to prove this, it's much easier, algebraically for me, to prove that something is positive, okay? Even though these are mapped to the same thing, okay? So how could I use that fact here? Well, here's my A, and here's my B, okay? So what I'm gonna do is, I'll say A minus B, okay? So I want this kind of thing, minus these two. Okay, so there's my A minus B, right? Now what I want to prove is that that's greater than 0. Okay? Yep. Okay, I will in a second. Okay? But here's the first thing I want you to notice, right? Which is that this is what I'm required to prove. So it can't be the starting point of my proof. Okay? It can't be the first line of my proof. It should be the last line of my proof. I don't know whether this is true or not. Or even if I do know it's true, I haven't actually shown it. Okay? So I can't start here and then do some algebraic stuff and then get to some statement which may be true and then say, therefore, my starting line must have been true. Okay? And I've said this lots of times, right?
Can you reverse engineer it and then rewrite it?
Yes. But you might as well just write it properly the first time. Okay? And the reason why is, you can do this with all kinds of things. Right? You can start with a false premise and then do legitimate mathematical things to it, right?
Or divide them both by 0.
You can do, well, dividing by 0 is not a legitimate mathematical thing, but squaring both sides is a legit thing.
Multiplying both sides by 0.
That's fine. Okay, multiplying by both sides by 0 is also legit. Okay, and then say, cool. If I ended at something right, then the premise must have been right. Right? Wrong. It's not. Okay. So that's why you can't start at this point. Okay. So don't do this. Instead, let's start at this, okay? Now, what can you do with this thing? I want to show that this is positive, okay? So I want to get some squares involved because squares, number 1, are already in here, and number 2, I know that squares are positive. Okay? So how can I get some squares out of this? What way can I arrange it to show that there are squares? Well, I think probably the easiest way to factorize, this is a, what's it called? Trinomial, a quadrinomial, okay? When you have 4 terms, often the best way is to pair them up, okay? So which ought we to pair together? Yeah, I think the x squared and the x cubed, they have a common factor of x squared, right? So if I take in, maybe I should expand this sign so that I don't get my negatives mixed up. Okay, I'll pair up this x squared y with the x cubed. Okay. Likewise, I'll pair up the y cubed with the xy squared. Okay, so now my factorization is really obvious. Okay, I can say, take out the x squared there, right? Take out the y squared here. Now what have I got? Okay, I've almost got a common factor again, right? What do I have to do in order to make it a common factor?
Minus sign.
Yeah, this negative, I want to turn that around, okay? So if I have this still out the front and turn that into a minus sign, right? Y squared x minus y, okay? Now I've got a difference of squares happening, okay? Now, this is better. It's factorized, whereas this was just a mess, okay? But it still won't do. I don't know, like a difference of squares can still be negative, right? If if the square is smaller than this one. And this one, I know that they're not equal to each other, but I don't know which is bigger, right? They haven't said anything about which is bigger, okay? So this isn't enough. What else could I do? Okay, so let's factorize again. Okay, so now you can see where it's going, right? Now that I've got 2 lots of x minus y, I can get rid of this. I've got x plus y out the front, and then I've got x minus y all squared there. There we go. Okay, now at this point, usually I'm going to, this is sort of like my last line of real working. Okay, I can conclude in a second. Usually at this point, I have to invoke my conditions, okay? And I'm going to write something really nice and succinct here, okay? But because we're just starting out, I want to make sure you guys understand why I'm putting these conditions here. I'm going to write this in longhand. So probably you won't need to write this out in as much detail, okay? But I want you to understand why it's there, okay? I've got a product here, right? And I want it to be positive. That's the point of me doing all this factorizing, right? So if I want a product to be positive, I've got two alternatives. It's just two things, right? I can either prove that both of them are negative, right? Because negative times negative is positive. Or I can prove that both of them are positive, and then I'm fine, okay? So in this case, which is it?
Positive.
They're both positive, right? So I got two, and I should deal with them separately. So x plus y, right, is greater than 0. How do I know? Because each of them individually is positive. So when you take the sum, that should be fine. Okay. Now, x minus y, careful. Just now, I rubbed it off already, but I said that if you square something, it could be, you know, you've got a boundary here, right? But this won't be useful, right? If I take something which must be positive, and something which is sometimes positive, but sometimes it's 0, okay? I'm not guaranteed that the product will be positive. So how do I get rid of this boundary?
X isn't equal to y.
Yeah, that's right. The only way it would be equal to the boundary is if x were equal to y, but it's not. Right? Does that make sense? So therefore,
You have to write that.
yeah, now I'm getting there, right? So this depends on these two, right? So I've sort of got this happening. But this in turn, this one depends on this. Does that make sense? And this one depends on this. So you can sort of see how, why am I saying that this, why am I going to say this product is positive? Because of these. But why are these true? Because of my initial, what was given to me. Okay, does that make sense? So what you actually usually find to write, really, is this part. Okay, your foundation, really. Okay, so what it amounts to is usually you're just going to quote what conditions they give you. Okay, this kind of step here is sort of unnecessary. Okay, however, when I'm doing inequality proofs, I write them just so that I know, like, why did I invoke these? Because these are the important things, and I recommend, especially like we're just starting this out, right, that you put in this step. Okay, I think it's really helpful to clarify your understanding, and from a marker's point of view, so that I know that you know what you're doing. Okay, anyone can just copy out the conditions from the question without understanding why. Okay, but this is understand. Okay, question.
Why do they have to be integers?
They don't. They could be real. They could be real. It's just that's what the question says.
Wait, so if they're not all positive, will that, how will that affect them?
If they're not all positive, then I might not be able to say this. Because if one of them was a big negative number and one was positive, then this will not be true. And so even though this will be positive, I don't know. This is indeterminate. So the inequality won't be true. Okay. All right, now, I'm almost there. Remember I told you this is basically my last line of working. So having justified that this is positive, the equality can turn into, bless you, it can turn into an inequality. See that? Okay, so I'm going from this line to this line, and because that's a big step, that's what all of this explanation is about. Okay, you can't just jump there. This is like the crucial explaining part. Okay, so I can say since this thing which I started with, okay, since that thing is positive, that's positive. Now I just boot this guy over. And that's how you set out an inequality proof, okay? So I think the two things I want to draw to your attention are, number one, where do you start? You have to start with the expression and not say that an inequality applies to it. I can't assume it's greater than 0 because that's where I'm going to end, okay? So number one, your starting point, get it right. Sometimes it's obvious, right? Sometimes, as you'll see in these later questions, it's not so obvious, you've got to do some real thought, okay? Number two, when you're doing this crucial step, from the inequality, the equality, because it's just factorizing, to an inequality. You must justify it, okay? This is really, really crucial. And then you just tidy up with a conclusion. Okay? Any questions? Yeah, come on.
I thought we can't work backwards.
I haven't worked backwards. I just worked forwards. I've looked at this expression, right? And from here all the way up to here, all I've done is just been rewriting it in a more useful form. Okay, a form that I can say, now that I'm here, I know that that's positive. I can use some logic based on my initial conditions to say, this must be positive. Okay, so after I do all my simplifying, now I can bring an inequality in because of all of my reasoning. Okay, does that make sense? So what would be different is to start here, say, yep, it's greater than 0, and then do blah, 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 and move things around, and you would end here, you'd end here, but of course you'd end here because that's kind of where you started, right? So that's the difference. And even though it's a simple difference, people keep making that error all the way up to year 12. Yeah?
Well, won't you be changing the question if you move it onto the other side?
Okay, yes, good question. So the question is, am I changing the question? Like, am I changing what I'm required to prove by starting to work with this? Okay, and you do have to be careful, it's a good question to ask. The reason why this is equivalent to what I am going to try to prove, right, is because, did you notice, this is what I was working with, which is here. Now, what's the difference? It's not a rhetorical question. What's the difference between what I've been working with and what I was trying to prove? What is the difference? Now be careful. The difference between them is an addition-subtraction difference. Okay? Now, addition, subtraction, multiplication, division, we're talking about this. They're okay if you know what you're doing. Okay? Squaring, on the other hand, or moving things sort of like, how do I say this?
Multiplying things by 0.
Yeah, that's right. You got to. If I'm multiplying by things that I know properties about, then it's okay, right? But can you see? I haven't actually moved anything. I know it looks like I've moved this across, right? Moved here to here. But actually, this expression here, I can treat it independently from this equation. Okay. So it's not like I've moved it across and then I start doing operations to both sides, because this doesn't have a both sides. Okay. I'm just simplifying and rewriting the same thing over and over again.